again, so basically going over the questions or going over the do-it-yourself questions from the previous lesson took a little bit longer than I thought, so I just made them 2 separate videos. But this is actually the lesson, the 9-6 lesson, solving rational equations. So we've been dealing a lot with rational expressions, simplifying them, adding them, subtracting them. So at this point, we're now going to do the last thing that we need to do with them, which is basically to solve equations that have rational expressions in them. So here's an example of one of them. This is one of the ones where you end up having 2 rational expressions equal to each other. And these are probably, like, by far, in my opinion, the easiest ones to do. Because if you remember, whenever you have 2 fractions equal to each other, another way of looking at that is a proportion. And you learned a long time ago that to solve a proportion, you can cross multiply. And that's basically what we're going to do. In the process of doing that, you end up multiplying both sides of the equation by an expression. And so it is very important in these problems, because of all the fractions, that you always check your answers, because there can be what they call an extraneous solution, which is a solution that may work in the resulting equation but doesn't work in the original equation. And I'll explain that further as we go along. So right now, for the cross product, you're going to get 5 times x squared minus 1 equal to 15 times 2x minus 2. And then you can distribute here, you'll get 5x squared minus 5 equals 15 times 2, which is 30x, and then minus 30. And then you can try to move everything to the other side in the hopes that you might be able to have a factorable quadratic. So we're going to move the 30x and the 30 to the other side. So I have subtracted 30x to this side, which is why it's negative, adding the 30 to this side, which is why it's positive, and it's equal to 0 now. So the last thing I want to do is combine my like terms. So I will get 5x squared minus 30x, and then I can combine the 30 and the negative 5 to get positive 25 equal to 0. And when I factor this, because they all have a 5 in common, I will get x squared minus 6x plus 5. And then factor that guy, 1 and 1, and then 5 times 1, both of those negative, to get a negative 6. And so I will get x minus 5. Sorry, I don't want to. So x minus 5, x minus 1, and then there's a 5 out here. So when I solve this using the zero product property, either 5 equals 0, or x minus 5 equals 0, or x minus 1 equals 0. And we all know that we all know that 5 does not equal 0, so that doesn't matter. But in this case, we add the 5 to both sides, and x equals positive 5. And in this case, we add the 1, and x equals 1. So we get 2 solutions, 1 and 5, and then we have to check them. And I will show you how this is a problem. The 5 is not a problem. When you plug 5 into the original equation, you get 2 times 5 is 10, and 10 minus 2 is 8, so that's 5 eighths, not a problem. When you plug 5 here, you get 5 squared is 25, 25 minus 1 is 24, not a problem. But when you plug 1 in to this expression, 1 squared is 1, and 1 minus 1 is 0. So x equals 1 is what we call an extraneous solution. It does not work in the original problem. So the only solution we have is x equals 5. Okay, so we have to be very careful in this lesson that we're constantly checking our solutions, because it is very, you frequently get extraneous solutions, and so we want to make sure that you don't do that. So x equals 1 is an extraneous solution, but x equals 5 is an actual solution. So now you can try these two, and then I will give you an example of one where you can't quite cross multiply just yet. You can only cross multiply when you have a over b equals c over d. In other words, you have 2 fractions equal to each other. And right now we don't have 2 fractions equal to each other. We have 2 separate fractions that are then equal to this fraction, but this guy is a problem here. We need to either make this into 1 fraction, or we need to get rid of the fractions altogether. So it's actually a lot easier to get rid of the fractions altogether in this kind of a case when you have more than 1 fraction on either side. So that involves us finding the least common denominator of all of the fractions, of the 2x, the 5x, and the 2. So since these both have a 2 and that has a 5, then obviously our least common denominator is going to be a 10. And then they both have x. So our least common multiple, or the common denominator basically is 10x. So what you want to do in this kind of a situation is find the least common denominator and then multiply each fraction by that least common denominator. So we're going to put 10x over here, 10x over there, and 10x over there. It's very important that you multiply every single fraction or every single term by that denominator. So now what we're going to have here is 10x times 1 over 2x minus 2 over 5x times 10x, and then equal to 1/2 times 10x. And what this does for us is it actually helps us get rid of the fractions. So in other words, there's an x on top and an x on the bottom, so it cancels. 2 goes into 2 once, and 2 goes into 10 5 times. So now we get 5 times 1 is 5. We have our minus there. In this case, we have the x on the bottom, the x on the top, so it cancels. And then 5 goes into 5 once, and 5 goes into 10 twice. And then 2 times 2 is 4. So we have 5 minus 4. And then on this side, we have the 2, and the 2 goes into 2 once, and 2 goes into 10 5 times. So 1 times 5x, because the x didn't cancel this time, 1 times 5x is 5x. And now this equation is not very hard to solve at all. 5 minus 4 is 1. We divide by 5. And so x equals 1/5, and we check our solution, and it works fine because as long as the bottom doesn't equal 0 when I plug in 1/5, I'm okay. And so when I plug in 1/5 to this guy, I'm going to get 2/5. And when I plug in 1/5 to this guy, I'm going to get 1. And that's, neither of those is 0, so that means that x equals 1/5 is a perfectly good solution. So that is what you want to do when you have, when you don't have just 2 fractions, you have more than 2 fractions. You want to find the least common denominator and multiply each fraction by the least common denominator to get rid of the fractions. So you can now, oh, by the way, this is, don't skip that, sorry. You can now try this one. Remember to multiply all 3 things by the least common denominator and then proceed. Once you've done that, you will have completed the lesson for today. Thanks for watching.